Okay, here is example number 3. Okay, so we have a story problem. We're going to use systems of inequalities to figure out if what is appropriate and what isn't. Okay, so tours. A Niagara Falls boat tour company charged $19.50 for adult tickets and $11 for children's tickets. Each boat has a capacity of 600 passengers, including 8 crew members. Suppose the company's operating cost for one boat tour is $2,750. Write and graph a system of inequalities to represent the situation so the company will make a profit on each tour. Then identify some viable solutions. Okay, part A, write the system of inequalities. Let A represent the number of adult tickets, and C represent the number of children's tickets. So here's one inequality that we can write. All together, so we have A amount of adult tickets, C amount of children's tickets, and then 8 for the crew. Okay, and all together, we have to have less than how many? As stated up here in the question. It says each boat has a capacity of 600. So we cannot have any more than 600. That is the max. Okay, inequality number 2. Blank A plus blank times C is more than 2750. Well, in order to make a profit, we have to make more than 2,750. Okay, so how much are the adult tickets? Adult tickets are, let's look for it up here, $19.50 for adult tickets. So we're just going to put we could put $19.50, or we could just put 19.5. Well, we'll leave it at that, 19.50. And for children, how much does a children's ticket cost? It costs 11. So you have to have a certain amount of adult tickets and a certain amount of children's tickets to make a profit of 2,750. Obviously, the more adults that you take on the trip, the more of a profit you can make because they charge more for adults. Okay, inequality number 3, A blank, or inequality number 3 is A times, what do you guys think? Okay, so down here they graphed this first inequality, A plus C plus A is less than or equal to 600. And that is this line right here. Okay, so if you have 592 adults plus the 8 for the crew, you would have 0 adults, which would be here. Or if you had 592 adults and no children and the 8 crew members, this would be 600 as well. So this line right here is right here. Okay, and you can have 600, but you cannot have more than that. So everything below here is appropriate. Now this line here, if you put 1950 times A, 1950 is the price, and 11 is the price for children, it has to be greater than 2,750. So if you plug in values for A and C, that would be this line right here. So this, above this line is where you make a profit. Okay, so basically we're dealing with this region right here. Okay, this will satisfy both conditions. Okay, it gives us both a profit and it gives us both the capacity as well. Okay, so let's go ahead and scroll down here. So if we have 60 adults and 100 children, let's see if that works. So here's adults, 60, which is probably about here, and 100 adults. Does that fit in the green area? It does not. It does not satisfy both conditions. So this is non-viable. Let's take a look at the next one. We have 210 adults and 350 children. That's way up here. Does that satisfy the condition? Indeed it does. So this is viable. Let's take a look at the next one. 415 adults. 415 adults and 200 children. That should be right here in that blue area. It does not satisfy both conditions. Okay, and you can tell by looking at both of these. 415 plus 200. That's more than 600. We can't do that. It's non-viable. Let's take a look at the next one. 390 adults, 240 children. Just by looking at this, I can tell that's too many people. That's going to be more than 600. So this is also non-viable. And can they take 550 adults and 0 children? So 550 adults, 0 children, that indeed is in the green region. Okay, so that is viable. Okay, that concludes today's lesson. If you have questions, feel free to rewatch the videos and have fun. All right, take care, guys.